This video is going to go over stats, section 4.2, which is titled simple random samples. So that will be abbreviated as SRS sometimes. So the definition is that a simple random sample of size n is chosen so that every group of n individuals in the population has an equal chance of being selected. So the big idea is that we're creating something that is fair by creating a simple random sample. So some qualifications for it to be a simple random sample is that they must be created from a list of every member of the population. So I have to have the entire population to draw from. And then each group of size n is equally likely to be chosen. So what this means really is that I can't like divide the population into groups and then go from there. So I have to be able to have these infinite number of groups that are all equally likely to be chosen. And that there are no restrictions placed on the sample. So SRS is a form of sampling without replacement. That means that each individual can only be selected once. So if I'm selected for the sample, then I'm in the sample. I can't be in the sample twice. So just some examples, SRS is drawing names or numbers on equal size papers after mixing them up. So when you're looking at some of the quiz questions, be careful in that they have to make sure that they emphasize that they wrote down the name or the number on equal size papers, mix them up, and then drew the names or numbers. Also using random digits that have been generated to identify members. And we'll go through an example of that like they did on the main video. And then as you're answering the questions, they're going to give you situations and ask if they're simple random samples. So just a reminder that simple random sampling is not drawing the first name or number, then picking every 10th, 50th, I think they did in the example in the video item after that. So when he was picking the apartments, right, he drew the number 12 and then he took and he wanted 5 apartments. So he just added 50 to 12 and then added 50 to that and then added 50 to that until he got 5 apartments. So that's not simple random sampling because once you pick that first number, the rest of the numbers are predetermined. So that means that every group of n isn't given a fair chance, right? Someone that is in apartment 13 now has no chance, even though they should get a chance as that second person that's picked, fourth, third, and so on. It is not a convenience or voluntary response sampling. So if you see a situation that identifies one of those two that we learned about in the last lesson, then it's not an SRS. It's also not an SRS if you ask everyone in the population or grouping items in the population in any way. So if I like group things by age or by where they live, and then I pick things, and then I pick the same number of people within each group, that's not a simple random sample. So what we're going to go through in the last part is using the table of random digits. So just to kind of go over those 3 steps, remember it was assign, where you take whatever your population is and you assign a number to every member of the population. And so we'll practice what ways we do that with the first example. And then you randomize. So you get this list of random numbers. So that part's done essentially for you. You just have to translate that to your numbers that you've assigned to your population in the labeling section. And then you select. So once you've found your numbers that relate to your population, then you translate those back to the items in the population that you assigned those numbers to. So just to practice, remember that there's essentially 2 ways that I can assign the numbers. So I want to use the least number of digits possible. Most of the time, that's going to be the number of digits that we have in the value. And so that means that if I have a number 35 that has 2 digits, I should be using 2 digits to assign the numbers. The only situation that's different is if I have the last or the first number of the next set of digits. Like they use the example of 100. For 100, I don't want to use 0, 0, 0, whoops, 1 extra 0, sorry. I don't want to use 0, 0, 0, 1 to 100. because what's better is 0 to 99. Okay, so only that first number, when the number of digits increases, is that relevant. So like 1,000, 10,000, so on. You would always pick the number of digits lower. For any other number, it's always going to be the same number of digits that has. So for 35, I can set two different labels. The first way that I can do it is by counting the first number as 1 and then the last number as the number that was given. The other way that I can do that is by counting the first number as 0, which would make the last number as 1 less than the number of items that I have. So then for 110, it would either be 0001, because there's 3 digits, to 110, or it would be 000 to 109. For the last one, I have 4 digits, so I'd either do 1, 2, 3 zeros to represent 1 to 1297, or I would use 0000 to 1296. Okay, so you're either starting at 1 and ending at the number, or you're starting at 0 and ending at the digit, the integer before that number that you're given. So in the last example, we're going to go through just the process of using those randomized numbers to select the sample. So we have the owner of a greenhouse that wants to test the effectiveness of a new fertilizer on African violets. She has 60 violet seedlings that were grown for 8 weeks. She wants to test a new fertilizer on 10 of the plants and decides to use a random number table to select the simple random sample. She labels the violets 1 to 60, right? So she chose that first option because she had 60 seedlings. Refer to the given line from a random number table, which numbers represent the first 5 plants selected. So we want to find 5 numbers that represent the plants. Remember that no replacement is allowed, meaning if I get the same number twice, I'm ignoring it. Okay, so this tells me that I need to include any numbers 60 or less. So as I'm looking at this, I have 2 digits. So I'm going to take 2 digits from here. If that number is 60 or less, then it's a number that's part of my sample. So 60 is, so that means 60 is the first number in my sample. Next 2 digits are 63. That's not 60 or less, so I'm going to ignore it. Then I've got 37. So my next number is 37. Then I've got 80. 80 is bigger than 60. So I'm going to ignore. 34, though, is in my sample, or sorry, in my population. 99 is not in my population. 60 is in my population, but it's already in my sample, so I can't use it again. Okay, so that's a repeat value. So I'm going to ignore it. The next one I get is 28. 28 is in my sample because it's part of my population and it's not already there yet. So I've got 4, I need 5. Next one is 34. Notice 34 again is a repeat, and so that means that I'm not going to use 34. However, the next one is a new value that's below 60, so 40 will be the last of those first 5. Okay, so when I'm doing that, I'm looking for numbers that are 60 or less because that is my sample population numbers. And then I'm picking the first 5. I ignore any repeats. Okay, so that's all that was gone over in this lesson. It's a lot of reading. Hopefully it's straightforward enough and you can identify what a simple random sample is.